This video discusses string literal and variable objects. These are some of the basic objects you will be exposed to when you first start learning how to program the computer. Of course, there are numerical objects. There are objects that allows us to create a list of data. There are sets, dictionaries. There are a litany of objects, but some of the basic ones that you'll be exposed to would be string literals versus numerical objects that can be stored in variable names. So by the end of this lecture, the students will be able to distinguish between what a string literal and a variable object is, understand how Python handles memory and mutability. That's a second objective. A third one would be to use flowcharts to help visualize the layout or the solution of your problem. And finally, you want to be able to apply the concepts through pseudocode and Python code. The pseudocode is really an outline in plain English of how the problem will be solved. And we're going to demonstrate that momentarily. String literal objects are objects that are consistent of a fixed sequence of characters, and they'll be enclosed in quotes. It could be double quotes, double quote John Brown, double quote, or a single quote. The reason for this is that this acts as a way to begin where the string starts and end and where the string ends, and sometimes we call these delimiters. And so that's why you find that we will have string literals enclosed in single quotes or double quotes. One characteristic about a string literal object is that it is immutable and it cannot be changed after creation. It can be stored inside a variable name, and you can change the variable name itself, but that object is immutable and it cannot change. So looking at the pseudocode or the plain text design tool to express a string literal, all you would have to do is say print and then double quote John Brown, double quote, or single quote. Either one of those would work. So the John Brown is a string literal. It is immutable, cannot be changed after creation. The flowchart design tool is a visual design used to help describe how the problem is solved. And so we use the oval shape start, and you see the path of the direction using those connecting arrows. We have a parallelogram or rhombus to indicate that we're either inputting something or outputting something. So in this case, we're saying print or output John Brown, and then we end, or this is where the flow diagram or the logical flow ends. Here's what it looks like in Python. We will go into the idle, and I'm going to show you all that in another video. We go into idle, and the way you know you're in the idle or the integrated development environment is that you're going to see a menu. If you don't see this menu, that means you're not in the integrated environment. It might be the shell itself. But even if you're in the shell, that normally shows up. But however, we'll show you how to log into Python momentarily. So we're going to start off with a remark. Remarks are very important. The way you create a remark is you start off with a hashtag, and then you write out what you want to say to describe something. In this case, I'm saying string object defined in the print function. And then I'm going to use a predefined function in Python called print. And the way you know this is a function is that it'll use the reserved word print followed by an open parentheses followed by the object that the print function will use, followed by close parentheses, and then we indicate where our program ends. It is always important to start off specifying what's going on in this program. As a matter of fact, that's one of the biggest complaints we get from employers, that their beginning employees or students who do internships do not know how to document and write out comments. And that's one of the things that we're going to emphasize in this course. It is going to be essential that comments are throughout your program. So when we execute or run this program, it's going to write out John Brown. So when we say print, open parentheses, double quote, John Brown, double quote, and we run, it's going to display John Brown literally. So whatever is literally between the quotes, whether it be single or double, is going to be displayed on the screen, in this case on a monitor, and in some cases, if you tell it to write it to a file, it will also do that. Variable objects are objects that reference values. So a variable object is a named reference to a value. It is stored in memory, and it can point to any data type and be reassigned. That's why we said a variable object can be mutable or immutable. If it is a string literal, it is immutable. It doesn't change. If the variable contains a value that could change based on how you set up your program, then it can be immutable. Basically, the variable itself is not mutable or immutable. It has to do with its object that could be mutable or immutable. So the name is a variable object that stores a string of characters or a string literal. It is immutable. It can point to different values over time. And then if that's the case, if something changes, that means it is going to be mutable. Now in this next example, which is the pseudocode, begin, set the name to John Brown, and then we print. So when we use the variable name, we assigned it to a particular value, and then we tell the computer to print it. Begin and end are just plain text to let us know where the program begins, what happens in between, and then it ends. Anything that's indented indicates that these are the steps that are going to be executed between the begin and end. The flow diagram, using the same concept, that is a variable to make an assignment, will display as follows. Start, the oval shape. This time we use a rectangle symbol, which indicates we are making an assignment, or the process is taking place. Anytime you see the rectangle symbol, that means a process is happening, or some sort of a assignment is going on. And followed by that, display the results using the print statement, and we use the oval shape to end. So oval to begin, rectangle for processing, and input output we use a parallelogram, or sometimes we refer to it as a rhombus. And then of course we end using the oval shape. Here is what the program looks like when we express it in Python programming language. And when we execute the program or run it, it's going to display John Brown again. The output doesn't look different. It's just how we're telling the computer to perform the task changes within the Python itself. Now suppose we wanted the user to be able to enter a string literal data. So we make the program interactive. So in pseudocode, we would say begin, ask the student to enter name, rather than having the program to assign a value. We're going to ask the user to enter the value and print the results. Print the name. As you can see in the pseudocode, begin, ask, print, and then end. Here's what the flow chart looks like, where we're allowing the user to be interactive. So we start, ask the user to enter their first and last name, and then the program prints the name. Notice that both the input and the output are parallelograms or rhombus. And at the end, we have the end oval shape. The next video continues with the discussion of string, literal, and variable objects. Stay tuned.